This is Unit 1 of Edexcel IAL Physics. We started the topic Mechanics in Material, and the first topic, Mechanics in Material, we discussed the SI or the base quantities with their units and the prefixes which we use, as well as we discussed the slope of the graph. Then experimental uncertainties. What are experimental uncertainties? When you carry out the experiment, may, due to the apparatus you are using or due to a certain change in condition, you might have errors in your result. So that we refers to uncertainty. So what are the types of the errors? How we define the errors? So first one is known as a random error. So what is the definition or meaning of a random error? Basically, what happens when you are carrying out the experiment? Example, you're finding the effect of temperature on the resistance of the metal, and we know that as the temperature changes, or you're finding a relation between voltage and current at a fixed temperature. But what happens when you're using the a filament or or a bulb or a circuit for a longer period of a time? So it produces heat energy, and that heat energy can cause a change in temperature. So as the temperature change, the ratio between voltage and current will also change. So when the error is there in your result due to sudden change in condition, that is known as a random error. So random error upon multiple measurement will result in reading being scattered around the accepted value. So if you have a random error, how you can identify that you have a random error? Like example, a student performed the experiment, he is finding the acceleration due to gravity. The exact value of the acceleration due to gravity is 9.8 meter per second square or 9.81 meter per second square. But the student result, this is what the student result shows. Like he got one of the value as say 10, he got another value as 11, then he got another value as 8, then he got another value as 8.7. So the when the values are actually fluctuating between the standard value or the actual value, we call or we can identify that this experiment is having a random error. Is it clear? The concept of a random error, that your result will be more spread out around, or your result will be spread out around the actual value. So if you plot a graph, from the graph how you can identify there is a random error. So the reading, when you draw a best fit straight line, the reading will be scattered. So on y-axis you have one quantity, on x-axis another. And what about your readings? Your readings are scattered around the. So this shows that our result is having a random error, because like sometime the value which we are getting is higher than the actual value, and sometime the value we are getting is lower than the actual value. So random error upon multiple measurement will result in a reading being scattered around the accepted value, and this can be reduced by repeating or taking an average result or plotting a graph and draw the best fit straight line. Example, reaction time, your random error due to reaction time, temperature fluctuation or pressure fluctuation, that may leads to a random error. But what about systematic error? The definition of a systematic error, a consistent error which cause the reading to be larger or smaller than the accepted value. And this cannot be eliminated by repeating or taking average, such as zero error or calibration error or the parallax error is there. So when the readings are there, how you can identify, like the say another student, this was a result of student A. That student A performed the experiment, he's getting 10, 11, 8 and 8.7. So he's getting higher values also and he's getting lower values also. So it shows that this result is having a random error. But another student performed the experiment and due to finding the expression due to gravity, and his results are like 9.8 meter per second square, 9.7 meter per second square, 9.3 meter per second square. So all the values you can see are less than the actual value. So either it's not necessary all should be less, but if it's less or if all the values are more, so we can identify that our result is having a systematic error. Like, and systematic error can be due to the zero error when you're using a micrometer, or calibration error, you did not calibrate the meter correctly, or a parallax error. So when you plot a graph for this error, so how it will appear your results. And all the values will be higher or lower than the actual, but it cannot be higher and lower both. Either all will be higher or all will be lower. Is it clear the definition of systematic error? So first we discussed the random error, and then the second one is systematic. Random error can be minimized by taking an average, repeating the experiment, taking average. But systematic error is always like if it's there in the instrument, then by taking or repeating the average or repeating the experiment or taking an average will not reduce this systematic error. So zero error, calibration error, parallax error are the example of systematic, where random error due to the fluctuation in the reading. Then what is the difference between accuracy and precision? The term accuracy shows that a measure of how far away from the mean is from the expected value. So our average result, how far it is from the expected value, we call that as accurate. So example, and this can be improved by reducing or eliminating systematic error. So if we remove systematic error, we can have more accurate results. So example, a student C is finding the acceleration due to gravity. So his results are 9.81, 9.83, so 9.85. So you can see the student values or student results, the average, when I take the average of 9.81, 9.83 and 9.85, the average will be closer to the actual value. So means student C is accurate. But another student performed the experiment. Another student performed the experiment. He's getting 10, 10.1, 10.2. So which student is accurate? Student C or student D? So student C, the average is closer to the actual value, so C is accurate. So it's, if we are, and what is the meaning of precision? Precision means how close the repeated measurements are there. Like when we have two values, student two students are performing the experiment to find the acceleration due to gravity, which is 9.81 meter per second square. One of the student got the value 9.8, 10, 15. This is a result of student A. Another student got the result 13, 13.2, 13.5. So the question is, which student is accurate? When you check the accuracy, you have to check the mean. When we take the mean 9.81, 10 and 13, so that mean or average will come closer to 9.8, so it means student A is accurate. And if the question is which student is precise, precise means like results are, the repeated results are closer. So 9.81, 10 and 13 repeated results are not closer. But you can see student B is precise but not accurate. And student A is accurate but not precise. Is it clear the difference between the accurate result and the precise results? So these definitions are important. You should understand the fact that the difference between the precision and accuracy. Then the difference between displacement and distance, that like example, if there is a water pond and a person walk around the pond and take this path, so the difference between the 2 points is called distance. But for example, a person swim across this pond and reach point B, so he took the shortest distance. When we take the shortest distance between the 2 points, we call that as displacement, and displacement is having a direction. So whenever a quantity is having a direction, we call that as a vector. But if it does not having a direction, we call that as a scalar. So distance is a scalar quantity, displacement is a vector quantity. But some examples, distance and displacements are same. So when the object is moving in a straight line, in that case the distance and displacement have the same value. Like example, object is at point A, object is at point A and it moved to point B. So an object covered 3 meters. So as it does not change the direction, so in this case the distance moving from A to B, that's 3. And what about displacement? That is also 3 meter, but displacement is a vector quantity, so north, south, east and west, or you can say right. So in this example it is moving towards east, or you can say it is moving towards right hand side. So whenever object move in a straight line, in that case the distance and displacements are same. Then the definition of a speed, how we define a term speed. We use the speed to describe how fast the object is moving. So speed is defined as distance travel in a unit time. So how much distance traveled by the object in a unit time, we call that as a speed. And speed is a scalar quantity, so the total distance divided by total time, we will get that speed. But what about the velocity? The same thing, if we write the formula for velocity, so velocity is actually displacement divided by time. So if I say an object is at position A, okay, it moved to position B, which is 4 meter from A, and then it returned back to A. My question is, what is the distance traveled? So in this example, the distance traveled by this object, that is going 4 meter and returning back 4 meters, so distance travel is 8 meter. Just a minute, I'll be back. So in this case, the distance traveled by the object is 8 meter. But when we say the displacement, what is the displacement? So object start from A, then travel to B, and then return back. So if this displacement is a vector quantity, yeah, that's right. If this is plus 4, this will be minus 4. So displacement will be 0 meter. Example, the object took like travel from A to B and then returning back to A, it took 10 seconds. So if I say what is the speed? So speed is distance traveled divided by time. So distance is 8 and time is 10. So 8 divided by 10 is 0.8 meter per second. But velocity is a vector quantity. So what about velocity? So velocity, because displacement is 0, so 0 divided by 10. So the velocity will be 0 meter per second. Is it clear, this example? Then acceleration, how we define the term acceleration? Acceleration is refers to the rate of the change in velocity, how the velocity changes from one position to another. We call that as acceleration. And the formula to calculate the acceleration, like if we have an object at position, starting velocity is u, final velocity is v, and it took time t from moving from position A to position B. So acceleration is the final velocity or change in velocity, final minus initial divided by time. An acceleration of an object can be zero, it can be constant, it can be increasing, or it can be decreasing or deceleration. So acceleration of an object can be zero. What is the meaning of a zero acceleration? The term zero acceleration means speed does not change. Like example, if I say object is moving from one position to another, so at this point it is 2 meter per second. Here it is also 2 meter per second, 2 meter per second. Time is equals to 0, time is equals to 1, time is equals to 2. So when I calculate the acceleration here, the change in the, because there is no change in the velocity, so 2 minus 2 will be 0, 0 divided by 1, it will get 0. So here acceleration is 0 meter per second square. Acceleration can be constant. What is the meaning of constant acceleration? The constant acceleration means the speed changes with the same rate. Every time the speed is changing, but it is changing with the same rate. Like object is moving with 3 meter per second, then 5 meter per second, and then 7 meter per second. Here time is equals to 0, time is equals to 1, and time is equals to 2. So when we calculate the acceleration change in velocity, it's 5 minus 3, that's 2. So here 2 meter per second square, and here also 2 meter per second square. So acceleration is not changing or uniform or constant acceleration. Acceleration can be increasing. What is the meaning of increasing acceleration? Increasing acceleration means that the change in the velocity will increase. So example, in the beginning it is 3 meter per second when time is equals to 0, then it becomes 5 meter per second when time is equals to 1, and then it becomes 10 meter per second when time is equals to 2. So when we calculate acceleration change in velocity, so 5 minus 3 divided by 1, so it will be 2 meter per second square. When we calculate change here 10 minus 5, so it will be 5 meter per second square. So acceleration is increasing. Then it can be decreasing acceleration. There's a difference between, like, student get confused with two things that they are similar. There is one thing we call decreasing acceleration, and the other one is known as deceleration. Basically, decreasing acceleration and deceleration are different. Deceleration means the speed decrease. But in decreasing acceleration, speed does not decrease, only the acceleration decreasing. Example, in the beginning there is a greater change, but later the change is smaller. Like if I say an object is moving with 5 meter per second, changes to 10 meter per second, and then 12 meter per second. Here time is equals to 1, time is equals to 2, and time is equals to 3. So when we calculate the acceleration, change in velocity is 5 divided by time is 1. So 5 meter per second square. Here also change in velocity is 2 divided by time is 1. So 2 meter per second square. So you can clearly see the acceleration is only decreasing where the speed is increasing. But the term deceleration, the speed should also decrease. And then deceleration can be constant deceleration, or it can be a variable deceleration. So an object slowing down, first it is moving with say 5 meter per second, then it is moving with 3 meter per second, then it is 1 meter per second. Here time is equals to 1, time is equals to 2, time is equals to 3. So here the deceleration, final minus initial, so 3 minus 5, so minus 2 meter per second square. This is also minus 2 meter per second square. So this is a constant deceleration. A deceleration can be constant or it can be a variable deceleration. Is it clear, the concept of acceleration? Any question or a doubt till now? Then you should be able to use the equation for uniform accelerated motion in one dimension. So these are the known as the equation of motion. Four equations are there. S is equals to u plus v divided by 2 multiplied by t. V is equals to u plus at. S is equals to ut plus half at square, or v square is equals to u square plus 2as. So you have to memorize or learn this equation. What are the meaning? Where S stands for the displacement or distance, T is the time, U is the initial velocity or speed, V is the final velocity or speed, and A is acceleration. But that, if a falling object is there, if an object is falling or object is moving against the gravity of the earth, then when it is falling its acceleration will be equal to 9.8, and when it is rising its deceleration will be equal to minus 9.8. So these equations you have to memorize. Now we'll do some questions. The kinematic equations are there, acceleration, motion for, and this is valid only when the acceleration is constant. If acceleration is not constant, then we cannot use these equations. So example, the first example, a car accelerates uniformly from stop. So if something starts from rest, what will be the initial velocity u? So whenever an object starts from rest, object is starting from rest, initial velocity will be 0. At a rate, so this is the acceleration because meter per second square. Find the displacement. So we have to find the displacement. Basically, we have to find distance or displacement s, and speed. So after, so we need the final speed, and the time is equals to 0.82 seconds. So first thing, what you have to do, you have to write the four equations, and then the equation which is having only one unknown, you will use that equation to solve this question. So first I will write all the four equations, and then I will sort out which one is useful for calculation. So S is equals to u plus v divided by 2 multiplied by t. 2as equal v square minus u square. V is equals to u plus at, and s is equals to ut plus half at square. Now when we check these equations, because displacement and velocity, the final velocity, are unknown, so this is unknown and this is also unknown. So any equation which is having two unknowns, I cannot use that because two variables are there, so I cannot simplify that equation or calculate. When you check this one, displacement is there and final velocity, so again I cannot use. Here only the final velocity is the one which is not there, so we can use this equation to find the final speed. So when I use this equation to find the final speed, v is equals to u plus at. V is the final speed which we are finding. U is the initial speed 0. It was accelerating at 6.1 and the time for acceleration is 0.82. So 0.82 when we multiply it, so it will come out as 5 meter per second. So we got the final velocity. Now we have the final velocity, so we can use any of these equation, as this v is now known. So we have only one unknown. So if I use the third equation, so s is equals to u plus v divided by 2 multiplied by t. So u, the initial velocity is 0. The final velocity we worked out, that is 5 divided by 2 multiplied by time, which is 0.82. So when we multiply them, the distance will come out as 2.05 meter. So I can use any of the equation. Now, like as in this example, they use which equation? S is equals to ut plus half at square. They use the last equation and got the answer. But I can use, because as I know the final velocity, so I can use any of them to calculate the distance or displacement. Is it clear? The equation of the motion, this example. Another question. So a small stone is fired vertically up. So when you fire something vertically up, when it rises, it will have its initial velocity and its acceleration. Basically, it will decelerate according to the gravity. So minus, you have to substitute minus 9.8 meter per second square. And the final velocity is 0 because momentarily it will be at rest when it reaches the maximum height with a speed of 10. So that is the initial velocity. Find the maximum height. So we need a distance, or s. So what are the things which we know? We know the initial velocity, we know the final velocity, we know acceleration. So which equation can be used? We can use to calculate that acceleration. So when again I write the all equations and will work out. So we have the equation s is equals to u plus v divided by 2 multiplied by t. Then we have s is equals to ut plus half at square. Then we have s is equals to, or 2as is equals to v square minus u square, and then v is equals to u plus at. So when we check, uh, we know that this is unknown. We know the initial velocity, final velocity, and the time is not given. So the time is also unknown. So again, this equation is having unknowns, two unknowns. When we check this equation, only one unknown is there, that's a displacement. So we'll use this equation to as equal to v square minus u square. or you can also say v square is equals to u square plus 2as. So 2 multiply, now acceleration is due to gravity, but I have to substitute minus 9.8. Why I'm negative? Because it is decelerating. So v square, the final velocity is 0, and minus the initial velocity is, it is launched with a speed of 10. So when we simplify this, s is also there, the unknown. So when we need s, this whole will go there in division, and we'll get 5.1 meter. But as you can see, when they solve for acceleration, they took 9.8, and they're getting a negative answer. So what is the meaning of a negative answer? It shows the minus signs indicate that the direction of a displacement is opposite to direction of acceleration, and it is obvious here that object is rising against the gravity. That's why it is coming out as negative. Is it clear, this example? Then the second part, you should be able to draw and interpret the displacement time, velocity time, and acceleration time graph. That we'll discuss tomorrow. Now we'll do some questions related to the kinematics, the equations. So you can see a cyclist is traveling at a speed of 4.1. So that is the starting speed of the cyclist. Accelerate at 1.1 meter per second square. So that is acceleration in 7.4 seconds. So time is equals to 7.4. Calculate the distance traveled. So how we can calculate the distance traveled? So we have the formula. We will use equation of the motion, but which equation we will use, that depends on the quantities which are given. So the best thing is you write all the equations, and the equation which is having only one unknown and the desired unknown, that you will use. So like s is equals to u plus v divided by 2 multiplied by t, 2as equal v square minus u square, s is equals to ut plus half ut square, and then v is equals to u plus 18. So initial, we have acceleration, we don't know the displacement, that is what we need. And so we have initial velocity, we have acceleration, and we have time. So we can use this equation. So when I use this equation, the formula s is equals to ut. So initial velocity is 4.2 multiplied by time, it is 7.4 plus half, then acceleration is 1.1, and t square, so 7.4 square. So what will be the final answer when we solve this? It will come out as 61 meter. So C will be the right answer. Is it clear, this one? Tomorrow we'll discuss questions related to graphs. After explanation of the graph, I will discuss the question related to graph. So another question, an object of mass 8.2 kilogram. So we have the mass initially at rest. So initial velocity is 0. It falls vertically through a distance, so s is given. And we know the final velocity. Which of the following Okay, this is about energy dissipation, so kinetic energy minus potential. I was looking for the equation of the motion. I want everyone to solve question 28. A ball is dropped from rest, so initial velocity is 0, the height is given, and acceleration will be 9.8. Can you work out its final speed at which it hits the ground by using the equation of the motion? The equation which you will use, as you did not memorize, but 2as is equals to b square minus u square. So use this equation and work out the right option. So what could be the right answer for question 28? A ball which is dropped from certain height, its acceleration will be 9.8 meter per second square. Yeah, that's right. D is the correct answer. So today we discuss about the speed, velocity, and acceleration, as well as the equations of the motion. Any question related to the class today?